All right, so today what we're going to do is we're going to continue talking about the beginnings of algebra, right? And some of the stuff you've heard before, some things you've heard before, but it's really important for you to understand the language of algebra because it's slightly different than the language that you use in arithmetic. And if you don't understand the language, you're not going to understand what's being asked of you, right? So you need to know these words, these terms, okay? So what we're going to do is we're going to talk through some language that you need to understand, and then we're going to walk through some of the building blocks of algebra again. You looked at some of them yesterday, but we're going to continue that because it is so important. All right? So first, we're just going to go to the book here and look at some pieces of this. So the first word we have what's called a variable. Okay? Now, I'm just going to underline what you need. You don't need all of these pieces, but you should study this chart. A variable is an unknown value that's written as a letter or a symbol. So you can just write unknown value, comma, a letter or a symbol. Usually, it's a letter. We don't use symbols much, but you can. Usually, if you use a symbol, that means it is actually something you do know. You're just using a symbol to replace it. Okay? So, if you look at looking at the example they have given, we have P. We don't know what P is. It's just a letter that stands for some unknown number. So P. We have L and we have W. So those are our variables. And again, all it means is a number that I don't know the value of. So I can put any number in there as long as it makes the sentence true. Okay? That's important. The next thing we need to talk about is an expression. Now, I don't like their things, so I'm just going to tell you that an expression is a collection of terms. A collection of terms. And we'll talk about what a term is in just a moment, so you're not going to have to worry about that. So just a collection of terms. Okay. So if you look at this, 2x plus y minus 7. It's a collection of terms. 2a plus b over c, a collection of terms. Okay? And we usually define an expression by what it doesn't have rather than what it does have. And that brings us to the next one, which is something called an equation. And you can tell that it's an equation simply because it has an equal symbol. Now, you can call it a sign if you want to, but we've learned what signs are. Signs are positives and what? Negatives. This thing is not a sign. It's a symbol. It's a mathematical symbol representing an operation or representing an idea. It's not a sign. Signs are pluses and minuses. But since you learned it this way for your whole lives, I will tolerate you saying sign equals sign. But you should really know that it's not a sign. It's a what? Symbol. There you go. Yeah, at some point. So if you see these, neither one of those in the expressions had the equal symbol. But down here, we have 3x plus 8 equals negative 1. So this equal symbol turns an expression into an equation. Okay? So again, if you see the equal symbol, you know it's an equation. If you don't see it, then you know it is an expression. That's the only difference. Okay? Now, the most important thing we're going to look at today, terms. Now I'm going to flip over to a completely different piece of paper to write this out because we're going to talk about terms in just a moment. So don't worry about terms right now. Okay? It's really important. Okay, so let's just go to some paper so we can talk about terms. Terms are the building blocks of algebra. If you don't know all the pieces of a term, then you cannot do algebra. And it is one of the most common mistakes that students make is not knowing what a term is. And you literally can't do algebra if you don't know what a term is. That's like saying I can spell any word in the English language as long as I don't have to use vowels. Can't do it, right? It's just a ridiculous statement. So if you don't know the pieces of a term, and if you can't recognize them instantly, then you don't know how to do algebra. Okay? Every algebraic expression and algebraic equation are made up of terms. So it's so important that you understand them. All terms have 4 parts. Okay, I want to change that a little bit. All algebraic terms. Sorry about that. All algebraic terms have 4 parts. And I've used that word algebraic. If you see algebraic, that simply means it has a variable in it. That's the only difference between arithmetic and algebra, is that we have those letters that stand for some unknown number. They mean a number, right? But we just don't know what that number is. And so we put the letter in just to hold its place. So we can still do operations even though we don't know what the numbers are. Here they are, 4 parts. First part is its sign. Every term is either positive or what? Negative. Good. So from this point forward in your life, there's no such thing as a 4. There is a positive 4 and there is a negative 4. So get used to saying it. Just many students make the mistake of dropping signs, not because they don't know the sign rules, it's just because they just don't think about it. Right? So if you say positive and negative for every number you say, then it'll put it in your head that you need those signs. Okay? The second part of every term is something called the coefficient. Now I'm going to go ahead and write out these words, and then we'll look at an example of what a term looks like and practice pulling these up. Coefficient, now we've used that word before when we talked about brackets. It simply means a multiplier. And you're going to see that in a term, an algebraic term, that multiplier is always a number. So we'll look at each piece of it so you can identify each piece. We're just going to spend a whole lot of time. I'm going to write down a term, and you're going to tell me the pieces of it. Okay? It's that important. Third part of every term is its base. And because these are algebraic terms, and they're algebraic because of the variable, then the base is the variable, or variables, plural sometimes, because you can have more than one variable in a term. Variable, variables. Okay? Everything is based on the fact that it's an algebraic term, which is based on the fact that it has a variable in it. Does that make sense? So the base drives everything. If you think about the base, that's the piece that secures everything, right? The rest of the stuff just goes along with it. So think about how important the base must be. And the last thing, part of every term, is its exponent, if you have one. And remember, you might think of exponents as an index, indices, power, another word for it. Right? We went through all that when we talked about order of operations. Okay? So those are the 4 parts of a term. And it's critical that you understand those 4 parts of a term, because if you don't, you can't do algebra. You might get to some stuff, but at some point you're going to crash. Okay? So what I'm going to do is I'm just going to write some terms down, and we're going to identify the parts. I'll do the first couple with you, and then I'm just going to start calling on people, and I'm going to ask you to do it. So focus on what we're doing. So start off pretty easy. Here we go. -4, then an x, and then a 2, the exponent of 2. So the first thing I want to do is I want to determine what's the first part of every term? The sign. And you see a minus in front, so that means that this term is negative. Good. Then we have the coefficient, which is the multiplier. And for a term, the coefficient doesn't always mean this, but for a term, the coefficient or the multiplier is the number. So what is the coefficient or multiplier in this case? The 4. Okay? Now, when we're using a term, we usually use those pieces and take them together. So we wouldn't usually say the coefficient, the sign is negative and the coefficient is 4. I'm just asking you for each of those pieces separated. You would normally just say that the coefficient is negative 4. So these two pieces go together. And what they do is they literally tell you how many of something that you have. Now you do this all the time. If there were 5 cars in the parking lot, 5 is the how many, right? So that's the coefficient. Okay? All right, so equate it to things you already know. The next part, the third part of every term is its what? Base. And what is the base or variable here? The x. Excellent, good. Okay? Now, it could have more than one letter. And if that's the case, then they're both the base. And then finally, on every base, whether you see it or not, there is an exponent. And here, what is the exponent? A 2. And these two pieces also go together. Now, you'll use them, so when you're using them, you'll use them together. And they literally name the term. So just like a while ago, I said 5 cars. Cars are the kind of objects you have, right? That's the name of the objects. So here we have negative 4 x to the seconds. All right? So you see how it's read? So this is read as negative 4 x to the second power, if you want to put a word for it. Also known as, you could rewrite it as negative 4 x, and what's the special word for something raised to the second power? Starts with an S? Squared, there you go. X squared. Either one of those. Okay? So it's critical that you be able to name a term and talk about its pieces. But it's also important that you realize that they have 4 parts, but 2 of those parts go together to tell you how many, and the other 2 go together to tell you what kind of term. So you can never consider them all separately, right? You can name them all separately, but when you're considering it, you do them all at one part. Okay? Here we go. Let's look at this one. Say we have 3y with an exponent of 5. Okay? First of all, this is an algebraic term. How do I know this is algebraic? Has a variable in it. Exactly. Anytime you have a letter in it, that's the definition of algebraic. Okay? So it's an algebraic term. All algebraic terms have exactly how many parts? 4 parts. Good. What's the first part of every term? It's sign. But this one doesn't have a sign. Which means we can assume it's a positive. Exactly. Now, remember when we talked about signs, when we looked in the last section and we learned the sign rules, I told you that if you know that you make sign errors, then you write the pluses and the minuses, because that's the only way to cure it. Okay? So if you know you make sign errors, you could put plus in front of the 3, because it's not wrong. It's just writing a little bit more. Okay? The next part of every term, the second part is its what? Coefficient. And the coefficient's a fancy word for multiplier, and the multiplier in an algebraic term is always simply the number. So what coefficient do we have here? Be careful, the 3. Yeah, the coefficient's the number in front. Yeah, the multiplier. Okay? Remember, you learned yesterday that if you have a number right next to a letter, that means to multiply them together. So the coefficient is the multiplier. So that's a 3. What's the base? Y. What's the exponent? 5. Okay? Anybody want to be brave and read this term to me? Go ahead, yeah. Excellent. Perfect. This is positive 3y to the 5th power. So, what kind of term is it? It's a y to the 5th. How many of them do I have? Positive 3. You need to be able to do it all. Read the whole way. Okay? Good deal. All right. Now, you're not always going to see every piece of the term, but they're always there. We just did one. We didn't have a sign, so we assumed it to be a what? Positive. Okay? Now, here I am holding a pen, right? But I never say how many it is, but if you just say the name of something, you assume it to be how many? One. And the same is true of algebra. Okay? So let's say, for example, I had this term. This is an algebraic term, has all four parts. What's the sign? Positive. There is no coefficient or multiplier, but if it's just an x, how many x's do you assume that to be? One. So there's always a 1 in front of every letter, no matter what. Okay? What's the base? X, and the exponent is 3. Okay. Here is an algebraic term. Maybe I shouldn't use z's because you don't like the way I say it, and you don't even like the way I write it. Let's do this one. Here's an algebraic term. I know it's algebraic because it has a letter in it. It has all four parts. Doesn't have a sign, so I assume that sign to be what? Positive. Doesn't have a number, so I assume that coefficient to be what? 1. It has a base. What's its base? Y. It doesn't have an exponent. So we assume if we don't have an exponent, what do you assume it to be? No, be careful. It's a 1. Yeah. Yeah, we'll look at something to the 0 power. Anything to the 0 power turns everything into a 1, but we'll talk about that later. We'll cross that bridge when we get to it. Okay? So, if you don't see a coefficient, you assume it to be a 1. If you don't see an exponent, you assume it to be a 1. Okay? So, I'm going to write down a couple, and then I'm going to call on some folks so that you get a chance to tell me what the pieces are. So, you have your notes in front of you. So, don't panic. I'm going to walk you through it just like I did the others. Okay, so not every term is algebraic. This is another term, but it's not algebraic. Can anybody tell me why it's not algebraic? Are you volunteering? Yes, Ava? There's no variable, exactly. So this is what's called a constant term. And a constant term simply means a term that has no variable. There's no unknown, no value that this thing can be other than itself. So anytime you have just a plain old number, now then remember, numbers have signs though. So 3 is a constant term. It means positive 3. Can it mean anything else? No. So that's why they're called constant terms. Constant terms or number terms, we just prefer the word constant just because it reinforces the idea, okay? But if you call it a number term, that's perfectly acceptable as well. Okay? So, algebraic terms, or what is the other type? Constant terms. Okay? Good. Now, the next thing we want to talk about is something that, again, if you'll equate it to your everyday life, makes perfect sense. What we're going to talk about next is something called like terms. Like terms, don't write this part down because I just want you to think about this for a second. Like terms. Like terms mean that they have the same name. Like cars are like objects to other cars, right? Pencils are like objects to other pencils. Desks are like objects to other desks, right? But are desks and chairs like objects? No. We associate them together a lot, but they're not the same, are they? Okay? Now, what if I had 3 pencils in this hand and 4 pencils in the other hand? Would you say, oh, look, I have 3 pencils and 4 pencils? What would you do? I have 7 pencils, right? You would gather them together as one group. And that's why it's so important to understand like terms. Now, again, like terms are terms that have the same name. And which two parts of the term make its name? The what? Base and what other part? The base and exponent. So they have the same base and exponent. And that's what makes them like terms. Now, did I mention the coefficient? Nope. Did I mention the sign? Nope. Because I don't care. Okay? In a moment I'll care. But for right now, all I want to do is tell if they're like terms or not. So what I want you to do is I'm going to write down some terms. And I want you to tell me, are they like terms or not? So negative 7y to the second and negative 3y. Are they like terms or no? But they both have a y in them. But this one is a y squared and this one's a plain old y. So they're not like terms, are they? Ooh, same base and exponent. Two pieces of it, right? What about negative 10x to the fifth and 5x to the second? Like terms? Why not? This has a 5 right there and a 5 right there. That makes them like terms, doesn't it? Nope, because this 5 is the exponent. This 5 is the coefficient. Excellent. Okay. Good job, guys. All right, how about this? Are they like terms now? Yes. Because this is an x to the fifth and this is an x to the fifth. The coefficient has nothing to do with it, right? It's just the name of the term, and that's the base and the exponent. Okay? Now, you can have more than one letter. So what if I have an AB and 5 ABs? Like terms? Yeah, they're AB terms. Yeah? What if I have an XY and a YX? It's the same thing. This one's just out of order. By order, I mean what? You betcha. So an XY, and this one shouldn't be written that way. We always write them in alphabetical order, so that's really an XY as well. So if they're out of order, just put them in order so you can see that they're like terms. And that is why it's so important that we write them in order, right? Because otherwise you might not recognize them as being like terms. It's good? Heard all this before? Remembered it all too, right? Okay, let's look at what's next on our list. Okay, all right, we've talked about all of those. Okay, so what's a good example for here? Consider this this algebraic thing. Is it an equation or an expression? Why not? Why? No equals symbol. There you go. How many terms does it contain? Now remember, we haven't talked about this, but you can tell how many. Remember, you can always tell where one term stops and the next one begins when you see the front of it. And what's the first part of every term? There you go, the sign. So let's just circle these terms to make. So here's one term. How do I know that it stops right there? Because there's a negative. So here's a second term. Here's a third one. So do you see everywhere there's a plus or a minus, it's the beginning of a new term. So how many terms does that turn out to be then? 5. Okay, good. All right. So you're going to have to do some exercises like this. All right. Now, what is the coefficient of the plain old x term? Which one is the plain old x term? The first, second, third, fourth, fifth one? The second one. And what's its coefficient? But usually when we're talking about the coefficient, we also include the sign. So we're going to say what? -6. Okay? They're usually considered together unless they ask you to name the 4 parts independently. We name the sign and coefficient and the base and the exponent together. Okay? How about the x squared? Which one is the x squared term? The last one. And what's its coefficient? +1. Because there's no number, you assume it to be a 1. Right? Just like one pen. Okay? What is the constant term in this one? Sorry? Shh. Oh, be careful. The what? -5. There we go. That's the constant term.